And the first question is from the topic optical sources and detectors. It is for 1 mark. So we'll go through the question. So a optical fiber basically has two things. So if I draw an optical fiber, it will have core and cladding. So each one will have individual refractive index. So this is of refractive index mu2. So the refractive index are given as 1.641 and 1.422 for cladding. So what is the critical angle at which a ray will be totally internally reflected? So that means what should be the angle of incidence so that the light totally gets reflected and it traverses through the optical fiber. So if this is my incident light I, so we know from the Snell's law that cos theta of core equal to the angle should be under root of n1 square minus n2 square by n1, which is nothing but difference of the refractive index of core and cladding divided by the refractive index of the core. So here I'm substituting the values here, which is 1.641 square minus 1.422 square by 1.641, which is of the core. So on simplification I get the value of cos phi as 0.499. So I take the inverse of cos of the value, so I get it as 60 degrees, so which is nothing but approximately 0.5. So cos 60 is half, which is 0.5. So the angle of incidence with respect to normal should be 60 degrees for it to be totally internally reflected. So here the answer is 60 degrees.